Assalamualaikum, my name is MUHAIMIN bin RASHID. Now I will talk a little bit about the introduction of the Michelin company. Michelin's well-known travel guides are the result of the Michelin Group's long-standing dedication to improving mobility, not just by producing the greatest tires in the world, but also by offering information that enhances the overall travel experience. This dedication began in 1900 when the first Michelin guide, the Michelin Brothers brainchild, was written and distributed free of charge to motorists and cyclists, who outnumbered the 2,800 registered automobiles in France at the time. Now we move to the background of the Michelin company. The question is, who is the founder? It all began in 1889 in Clermont-Ferrand, which is a small French town, when brothers André and Edouard Michelin created their world-famous tire company, fueled by a grand vision for France's vehicle industry at a time when the country had only 300 cars. Now we move to the question in how is Michelin created? From 1905 to 1914, Michelin was founded on May 11, 1905 and lasted until 1914. By the end of 1906, the company had grown to over 50 employees and had to relocate from its South Kensington headquarters. The new Michelin headquarters debuted on Friday, January 20, 1911 and remained Michelin's London location for the next 75 years. And from 1915 to 1924, Michelin published the first numbered roadmap in the United Kingdom in 1921. This rise in middle-class car ownership has resulted in a significant increase in holiday travel by car. Next, from 1925 to 1934, to address hefty import taxes on automobiles and components, Michelin chose to construct a manufacturing in the United Kingdom. In 1926, Stoke-on-Trent was chosen as the location for the facility, which supplied domestic automobile manufacturers, shops and customers in the UK and Ireland. In November 1927, the first tyre built in Stoke-on-Trent was produced. From 1965 to 1974, the Red Guide to Great Britain and Ireland was reintroduced in March 1974 after a 43-year absence, which took 4 years to produce, with over 15,000 establishments examined and evaluated. The result was a list of 2,330 hotels, 331 hotels and 981 restaurants located throughout the UK and Ireland. From 1975 to 1984, by the mid of 1970s, the post-war prosperity of the 1950s and 1960s had all but vanished, prompting a major reorganization and the closing of the Belfast facility. However, Michelin thrived in Formula One racing at this time, securing 4 of the first 8 positions in the 1983 British Grand Prix. From 1985 to 1994, in 1986, Renzingraf is appointed as a co-managing partner of the Michelin Group, having spent 6 years at the Stoke-on-Trent plant as head of the laboratory. 1986 was a good year for Michelin, sponsoring the 4 TT production races on the Isle of Man and achieving a rise in UK profit to 56 million. In 1991, Uniroyal won a contract to build the largest civilian trucks ordered from a British manufacturer for many years. The Unipower $45 contractor was specified to run on Michelin tires. That's all from me, thank you.
Assalamualaikum and hi, I am AZAREENA AZMAN and today I would like to talk about how the Michelin tire are being manufactured. Here are some of the processes involved, which are mixing, extrusion, calendering and curing. Firstly, the mixing process of more than 200 different materials are being combined to manufacture the tire, which consists of natural synthetic, carbon black silicon, sulfur, plasticizing and vulcanizing agents. These different variety of raw material are used to produce components like flat or profile products, steel cord or fabric wires, and bead wires. After mixing, here comes the extrusion process. The rubber charge is dropped into a chute and fed by an extruding screw into a roll die. The extruder applies through conditioned pressure, which provides additional mixing of the compound through the shearing action of the screw. The compound is pushed through the die after the extruded profile is vulcanized in a continuous oven. It then cools to terminate the vulcanizing process and cut into length. Extrusion is also used for sidewalls, profiles, and inner liners. The calendering is a set of multiple large diameter rolls that squeeze rubber compound into a thin sheet, usually of the order of 2 meters wide. Fabric calendar produce an upper and lower rubber sheet with a layer of fabric in between. Calendars are used to produce body plies and belts. A crew room is a facility that houses hundreds of fabrics of wire spools that are fed into the calendar. It is all begun on the tire building drum, which is a rotating cylinder with a flexible center so that the edges can be brought closer to each other. Then a perfectly airtight sheet of synthetic rubber must first be laid down on the drop, which is known as the inner liner. This will act as an inner tube inside the finished tire. The second layer is called the casing ply because it contains of the framework of the parallel fabric cord, which we call as casing. This assembly is the vital substructure and consequently a key component in the radial tire set tightly against strip of profile rubber. Two high-resistance steel wire hoops, which are known as the bead wires. Bead wires hold the tire firmly on its rear end. The casing ply is then folded up over the bead wires to hold them securely in place. Other components are added on the same degree accuracy. Some tires have dozens. Then the sidewalls have been applied, which are made of the rubber, both flexible and tough to protect the tire from the side impact. By inflating the center part of the drum, the edges are brought closer to each other. The tire is shaped. Next to the next process. Two metallic belt plies needed to be applied and also reinforcing threading plies, which provide directional stability and mechanical resistance, have yet to be added. Fine but highly resistant cord certain these pliers, being laid crosswise to the casing board, it forms shapes retaining triangles. It is time to lay down to the thread rubber. This part of tire which have a thread pattern will be in contact with the road surface. The unfinished tire is then being put into the curing mold, which has all the tire markings and thread pattern. A curing bladder filled with the hot pressurized water forces the rubber back into the mold cavity. The hot water and steam around the mold starts the curing process. During the chemical reaction, the tire goes from plastic to elastic state. As the mold closes and is locked, the bladder pressure increases so as to make the green tire flow into the mold, taking on the thread patterns and sidewalls lettering engraved into the mold. Later, the transformation is complete and the tire emerges from its metal shell, the tire being given its final features and finished shape. The technology that Michelin use are the metal additive manufacture, which is known as the metal 3D printing, can produce these complex shapes, and it's for the tire design improvement. It starts by modeling the part design, which a 3D digital data file controls the operation. An electron beam is used to melt powder and generate the object. The material is laid down layer by layer to create the part in just a few hours. With this technology, Michelin is no longer go through difficult to use traditional technology such as stamping. Plus, additive manufacturing use less exact raw material needed. Thus, no more waste produced, and this design technology are much more flexible. That's all from me. Thank you.
Assalamualaikum, my name is MUHAMAD HAMKA, and today I would like to present defect or quality issues occurs in the process in the Michelin manufacture. As you can see in the slide, most common defect in the extrusion when using a rubber as a raw material is first die swell, and second is a bubble defect. Next, we proceed to the die swell definition. Die swell is also known as a extruded swell or a Barrow's effect. The die swell happens when the polymer stream is compressed by entrance into a die and followed by partial recovery or swell back into the former shape after exiting the die. In general, die swell happens when the polymer chain relaxes as a result of a rapid release of pressure. There are many factors can affecting a die swell, and first is a material. Material is the one factors that can affecting a die swell. This is because each polymer has different properties with elasticity effects. As you know, the polymer that has a material with a high elastic effect will cause a die swell increase. And second is matte temperature. As I mentioned before, each polymer has a property itself. So the matte temperature is crucial for a die swell effect. This is because higher matte temperature will lead to less die swell. Next, we proceed to the solution or remedies. There are several ways to reduce or prevent die swell effects. And first is decrease extrusion rate. It means we need to reduce screw speed. By reducing the screw speed, the extrusion process will have a longer time to prevent the tendency polymer to revert its previous shape. And second, we increasing the length of a die end. As I mentioned before, by increasing the length of a die end will cause the longer time of extrusion process. It can minimize the tendency of the properties polymer to revert its previous cross section. Next, we proceed to the second defect in the extrusion process, which is a bubble defect. As we can see from the diagram, the pinhole in the product were the mostly defect in the extrusion process involve rubber, which is a bubble defect. Bubble defect is a very common for rubber compound with low hardness. From my observation, the factor affecting the bubbles are the same those affecting the pinhole. There are many causes that can affecting bubble defects. First, moisture absorption. Polymer have a high moisture absorption, and some of a material in the polymer, such as polycarbonate, can degrade and weaken if a tiny amount of moisture is present. When the polymer heated, the absorption moisture will turn into a steam. Then the result is appearance of a bubble in the product. Next, polymer degradation. By overheating may produce degradation of the polymer material that is used. The degradation varies from one polymer to the other, and the degradation as its temperature is always close to its decomposition temperature will causes the polymer to produce gas that might be trapped in the material. Next, we proceed to the solution or remedies to prevent bubble defects. First, the material need to pre-dry. To remove moisture, the material must be pre-dry in a hot oven before loading into the hopper. By pre-dry the material, it can avoid the bubble defects. Next is provide vent in extruder. A vent must use in a extruder to remove the trapped steam. When a vent is used in the extrusion process, the percentage of the air trap is reduced. By providing vent, it cannot fully prevent the bubble effect, but it can lower the percentage of the bubble effect. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haiqal bin Hipul, and I will explain about element of IR 4.0 that have been applied in Michelin tire company. First, we need to know what is IR 4.0. IR 4.0 is a fourth industrial revolution which is related to a technology advance. Let's take a look at element of IR 4.0 that have been in Michelin tire company. There are many, but I think this two is very crucial in this Michelin tire company. The first element of IR 4.0 that have adopted in Michelin tire company is augmented reality, or is AR. And second is human-machine interaction. These two elements is the best among the other elements. Let's go through these two elements in more detail. Okay, The first element is augmented reality (AR). Augmented reality (AR) have used to research different ways to achieve goals that add more values in Michelin tire company, such as cobotic, human-machine cooperation, to improve progress on the production side, to manufacturing the tire to more faster and to more effective. Since 2014, the group Michelin has the desire to integrate more digital technologies into its production system. AR, in more specifically, can give more advantage for workers and the production itself, where it can give more performance to the worker, less stress, and many advantages that can give the worker and production. And lastly, the AR, augmented reality, can increase the production on making tire or maintenance and more related to the product. Next is a human-machine interaction. Human-machine interaction is a technology which is connect human-machine easily, where the group involved in setting up the entire ecosystem around human-machine dialogue. This cooperation work with Fetolab machine with the Pascal Institute, Labsco and Limos have to promote the interesting interface with great human-machine cooperation. As you can see in the picture, it's like a smartwatch with many configuration on the system where it can connect the workers or operator to the machine easily. Like where you can see that the worker wearing the watch in the wrist, where can they control the machine easily. Where the further when the workers or operator are far from the machine, or when the to alarm the workers. That's all from me. Thank you. In this element of IR 4.0.
Thank you, Mama Haiqal. My name is Muhammad HAFIZUDDIN bin Maris. I will be presenting to you about SDGs or Sustainability Manufacturing by Michelin. What is SDGs? SDGs is Sustainable Development Goals. The UN Sustainable Development Goals aim to end poverty, protect the planet, and ensure prosperity for everyone by 2030. There are 17 Sustainable Development Goals. Michelin have implemented goal number 9, which is build resilient infrastructure, promote sustainable industrialization, and foster innovation. On September 2021, Michelin Cross Climate is launching a new generation of 4-season tires. This is a further illustration of the group's all-sustainable approach and its commitment to investing and innovating in the development premium tires with very high added value. An all-season tire can be used all year round. It combines the technologies of summers, winters tires for driving on dry and wet surface in both winter, summer as well as on snow. The second goal is goal number 12, which is ensure sustainable consumption and production patterns. Michelin is working both to reduce the amount of waste generated by its tire production sites and to reduce the amount of raw material needed to manufacture tires while maintaining their rolling and braking performance and boosting durability. Tires' impact on natural resource, energy, raw material, water must be improved throughout their life cycle. Using a circular economy approach, The use phase accounts for 80% to 95% of a tire environmental impact. Michelin asks for drivers to promote better use of resources. This is for our strategy: reduce, reuse, recycle, and renewable. And last one is goal number 13, which is take urgent action to combat climate change and its impact. The group supports efforts to prevent climate change through a 2050 policy that defines 4 priorities of action. And the first one is reducing energy consumption due to tires by 2000% per kilometer driven by 2030. And the second one is reducing CO2 emission by 50% by 2050. And the third one is using its expertise and culture of innovation to develop long-range electric vehicles and integrating its product and service into a new form of mobility for people and goods. And the last one is supporting implementation of global carbon price. That's all from me and from my friends. Thank you for watching. Goodbye and Assalamualaikum warahmatullahi wabarakatuh.